This is the last problem on page 4 of the study guide and the first few problems on page 5 on the study guide. There are a few more problems on page 5, but they go with a different class, so you don't have to worry about doing those. So let's take a look at this one here. We didn't have time in the last part, so we'll fix it or finish it up here. So it talks about Ted's average speed for a 6-hour trip was 60 miles an hour. Oh, this one kind of looks familiar. We saw a problem just like this. So they're giving us the average speed. And so here we have, for a 6-hour trip, his average speed was 60 miles an hour. Okay, so 6 hours, 60 miles an hour. How far did he go? Well, you multiply the rate times the time, that gives us our distance. 36 with a 0, so 360. During the first 4 hours, okay, first 4 hours, they're giving us a time, he averaged 50. Oh, look at that, they gave us another rate. So all you have to do is multiply those numbers. Well, let's see what they ask next. What was the average speed? So we don't know what that speed was for the last 2 hours. Okay, we know the hours is 2. Well, we don't know the distance, but we can find it. If you subtract these two numbers, it'll give you the distance. Now all we have to do is do a division problem. So when we go ahead and do that division problem, we end up, oops, I see I made another error. Where do you think I made the error? Oh, right here. See, as I was thinking about it, I saw, well, I'm getting 60. And I divide 2 into 120. That doesn't make much sense because the average speed was 60. The speed that we get should be bigger than 60 because here the 4 hours we were only going 50, which is 10 miles under the average speed for the whole trip. It should be actually a lot more than 60, I think, because in order for us to go an extra 4 hours, well, only 2 more hours remaining, we have to go above this amount, above the 60 miles an hour, quite a bit above it to be able to just average at 60. So 160. Okay, this makes more sense. Did the division right now. So now we can go ahead and do that division of 2, and we get our answer. So there it is, 80. 80 miles an hour. Well, that's a little bit better than the last problem we talked about. Last problem, I think it was like, that was similar to this, was like 140 miles an hour. That was far-fetched, but this one seems a little bit more realistic. 80 miles an hour. You can do that on I-5. A little faster than the speed limit, but you can get away with it. So, next one, state the ordered pairs, input and output. Well, what are the ordered pairs? Well, input represents X, and output represents Y. So the input, the ordered pair for this one would be 3, 2. There's one of them. The next one would be negative 1, 5. And the next one, 0, 6. That's all we have to do. The last one, 8, 2. So that's stating the ordered pairs. It looks like you've got a couple of them. So let's try another one here. Here, these, when we have the arrow, that points to the output. So you're starting here at 3, and then you're finishing at 4. So this is your X value, and this is your Y value. This is called a mapping system. And the reason they like this is that you don't have to write as many numbers. You see, you can draw an arrow to the same Y value. If you have 5 occurring twice like they do, then they just drew the arrow from 1 to 5 and 2 to 5. So the ordered pairs would be 3, 4. We'd have 2, 5. And we'd also have 1, 5. Well, over here it's different. They want us to state the domain and range. Well, okay, so the domain runs along the x-axis. So D stands for domain, R stands for range, and if you think about it, you have x and y. Well, x comes first because this is an ordered pair. That's why they picked x and then y. Well, same thing with domain and range. See, D comes before R. So if you remember it this way, D comes before R just as X comes before Y. D represents X, R represents Y. So what are the domains? Well, our domains, let's write D for domains, are each of these X values, X components. So we have an X component here at negative 2. So this is negative 2, this is negative 1 right here. So we have negative 2, negative 1. Another x value here is positive 2, so 2. And this one here is 1, 2, 3, 4 spaces over, positive 4. So those are the domains right there. Let's take a look at the ranges. Ranges are the y values, so y values for each of these points. So let's take a look at this point. 1, 2, 3, 4. 4 down, so negative 4. That's one of them. And we have C is just 1 down, so negative 1. And then B is 2 up, so 2. And A is 3 up, so 3. So there it is. Domain and range. Well, the last two problems here, at least 62 and 63 that we're doing, are going to ask about a relation, whether it's a function. We should state why, and then also it says which is the range and domain. So domains represent the x values. So domains here are 3, 4, 3, and negative 4. So I didn't really need to represent the 3 twice, but I just went ahead and did it. Ranges are the second number, the 2, the 1, the 8, and oh, we got another 1. I'll just write it down. Now, is this a function? Well, when you're looking at a function, look at the domains. Do the domains repeat? Yes, they do. They do repeat. You see, 3, for it to be a function, the domain 3 should only have one range, but it has 2, and 3 also has 8, so it's not a function. The reason it's not a function is because the domain 3 has 2 ranges. Well, let's take a look at another one here. Again, same sort of thing. List the domains, list the ranges. Domains 6, negative 6, 4, 2. 6, negative 6, 4, 2. Ranges 1, 3, 3, 3. 1, 3, and the 3 repeats twice, or 3 times. So, is this a function? Well, do the domains repeat? 6, negative 6, 4, 2. No, they don't. It doesn't matter whether negative 6, 4, and 2, they all have the same range. Remember, it's that soda machine. Well, soda machines, they sometimes have 2 buttons for the same beverage because that beverage is popular. So, when we push this button, we get a certain soda out. We get soda number 3 out. But when we push this button, we also get soda 3 out. Well, it's because it's more popular. So they have more buttons to be able to have more of that type of soda. And also, if we press button number 2, we also still get that same one. So yes, this is a function. Is a function, and the reason is because each domain has one range. So that domain, negative 6, has one range. 4 has one range. 2 has one range. It could be all the same range. Doesn't really matter as long as they only have one. Taking a look at this next one, our domains. Well, we only have 2 of them, 3 and 4. What are the ranges? Ranges are 1, negative 2, and negative 3. Is it a function? No, it's not. Look at this one right here. This domain has 2 different ranges. No, the domain 4 has 2 ranges. So you can't have that because, again, going back to the soda machine, it's like pushing number 4 and we get 2 different beverages. We get maybe a Coke and then a root beer. Well, that's wrong. They made a mistake. They put the wrong type of beverage in the category for Coke or whatever. So you can't have a domain with 2 different range values. Well, is this a function? Try that vertical line test on the lines they give you. See, I drew a vertical line. It crosses twice. That means this domain, vertical line is a domain. This domain has 2 different ranges. So no, it fails the vertical line test. Vertical line test. So not a function. So there it is. Well, this one, see, this is a parabola, and if we go ahead and cross some vertical lines through, you see we're only getting it to cross in one spot. So that means each of those domains has just one range. So we'd say yes, it passes the vertical line test. So there it is. Those are the types of problems you'll end up seeing on this benchmark. Good luck.